Okay, welcome again. Once again, everybody. Muhammad, Shadow, John, Eniola, Muhammad Takib, Caleb. So once again, today's section will be hands-on with Eniola. But before the start of the section, please share your learning experience so far, and you can also share if you are having any concerns or questions, so that we can attend to that before the section starts. Thank you all. Eniola, in the meantime, I think you can set up and take over once you are ready. Good afternoon.
Yeah, good afternoon. How do I share my screen?
So at the bottom of this video chat screen, you can see screen where you see video, screen, mute, etc. Can you see it?
I can only see video, mute, and leave. There's nowhere to share screen.
Did you join with your laptop or phone?
My laptop.
Okay. Is it the web version or the app?
I downloaded the app.
Today? Or
No, I did yesterday.
yesterday? Okay, that means you have the latest version. So it should be showing. It should be showing screen. Did you see anything like more there?
I'm seeing 3. Okay, I can see it. Yeah, share screen.
Alright.
Yep.
Okay, so I think you can kickstart. We have a few people on call already. Yeah, your screen is up.
Yes, I know. I'm trying to just navigate through.
Okay.
Alright, can I start?
Yes, please go ahead.
Alright. Good afternoon, everyone. So I'll just get started. Yeah, so we are going to be looking at the intermediate version of the competition. So the competition starts in 2 days actually. So for the intermediate competition, the name of the competition is Monthly Insurance Claim Prediction. So we just want to see, using machine learning, if you can predict insurance claim. So like we discussed about in the last session, we talked about trying to understand the data first and foremost before like delving into a machine learning competition. So that is the first thing you do. You need to understand like the problem you are trying to solve. So but for today, we are just going to be discussing about feature engineering techniques based on the kind of data we are going to be working with. So first and foremost, I would just like to share, there's this article I wrote on. So what I did was, like, for 2021, we gathered competitions around cargo, Zindi, and some other. Let me check. Yes, so we gathered from cargo, AI crowd, Zindi, Tianxi, and driven data. So we gathered like all the competitions that was done. So there were about 83 competitions. And so what I try to do is try to figure out like what actually makes people win those competitions. So our target was the first, second, and third, since the first, second, and third are the people that are awarded prize. So we just try to see from their solution. Okay, this is the unique method this person used to win this challenge. Okay, what does this person do difference? So after the whole analysis, I found out here that, where is it? Oh, so I found out here that, like, so they are actually, they are not three, they are four, but the fourth one I excluded it just like for bias sake. So there are actually four winning edge. So the first one is the model. So like for most competitions, like if you are very good in model tuning and how to like build like complex models, that's actually a winning edge for competition. That's one. Then the second one is assembled model. So we saw that there are a lot of competition, that there are a lot of like winning solutions that had like assembled models. So people like to like join algorithms together. Let's say you are working on a particular problem, you just build several algorithms and just layer the whole algorithm on top of themselves. So that's the second thing. Then the third one, which is actually very important, is the feature engineering and preprocessing. So there's a way you are going to look at the data with domain knowledge and try to like build useful features from the data through like your feature engineering techniques and the rest. So for today, we are just going to like be discussing this third one. Let me just talk about the fourth one. So the fourth one is your computational power. So we also noticed that a lot of people, because of the kind of laptop, the kind of like computation power they have, their drive, their RAM. So that can also like, because if you have a good computational system, like your model will actually run very fast. But if your model is dragging, like you won't have like the time to even think about new ideas. But because like you have like very fast computing power, you're actually able to think about new methods to do like new algorithm. Okay, I want to assemble more, I want to create new features. So that's another thing. So for a machine learning engineer or a data scientist, like I think it would be actually good to invest in a very good laptop that will like give you edge in that kind of thing. Yeah, so and we also like try to dive in deeper into the assembled part. So when we were looking at the assembled part, we noticed that a lot of people focus on averaging, and I just found only one competition winner that focused on like the maximum. So averaging in the sense that, let's say you have two models that predicted, okay, let's say it's a regression problem now. We have, for a particular observation, a particular, let's say cat boost predicts 5, then SG boost predict, let's say 6. So averaging will tell you add 6 plus 5, then you divide it by 2. So that's like what the averaging does. Then in maxima, so how the maxima work is just like maximum. So we know cat boost predicted 6 and SG boost predicted 5. So what the maxima will do, you just pick 6, which is the maximum from cat boost. Yeah. So that is that, and we can see the picture of one winner here. So this is cassava leaf disease classification. So this is like the whole architecture of the winning solution. So if you look at it very well, we have like a pre-trained image net, fine-tuned or layered on RSNet. Then the mean was taken. This was the stage 1 model. Then stage 2 was using the pre-trained efficient net with mobile nets vet. Then sum this up, then use the maximum, then get your final prediction. Yeah, so that is this for that. So let's just dive into our own problem. So our own problem is monthly insurance claim. So I checked previous competition, because like the provider of this data set is Zimnat. So if you check previous competition of Zimnat, you'll notice like they have like a lot of like variables you need to encode, and apart from variables you need to encode, they have a lot of date time features. So we are just going to be looking at different ways to encode features, because like there is actually a way people use, which is the one auto encoding. So I know like that's a very common method, so we are not going to discuss that and label encoding. So we just move to like some new ways to encode those variables. So the first one that we are going to see is the mean encoding. So this is how the mean encoding works. So for example, if you have like a categorical feature, so this is Titanic data actually. So this particular variable cabin has this what's it called? Has this has its values. Let me put it like that. So we have A, we have B, we have C to N. So this is like the cabin. Cabin is like sections. So we have like section A, section B, section C, section D. So a neutral way to encode this variable is just do one auto encoding. One auto encoding in the sense that, okay, anywhere that the observation is A will be filled with 0. Anywhere the observation is B will be filled with 1. Anywhere the observation is C will be filled with, let's say, 2. That kind of thing, just like one not encode. Or another way we would do it is label encoding. So just like label encode, maybe A to have a value of 1, B to like that, 3, 4, 5. But one auto encoding will create like different sparse variable. So another special, let me not say special, another way of doing it is using main encoding. So what main encoding will do for you in encoding a variable is like you are going to group by and maybe take a particular. So for here, our target is actually survived. Like we want to know want to see if a user is going to survive or not. So here, how the variable was encoded is using the survived column. So we just group by the cabin, then we see the ratio of people that are in cabin A that survived. We see the ratio of people that are in B that survived C. So it's not necessary to actually use the target to actually like encode, because if you use the target, it will be actually hard to encode on your test. So most time what we do is we check for another variable with maybe less correlation with the variable we want to encode on, or just pick out like a new variable which is not your target. So you encode the cabin based on that. Then once it is encoded, you can just like add it to part of the feature you're going to use to train your model. So this is one way. So we just move to another way now. Okay, so this is like if you want to turn it to a function and just use it directly on your variable. Yeah, so this is it here. So this is the cabin that has been encoded here. We just see like their values. That is one way. So we'll just look at another way now. Another way is using the count and frequency encoding method. So this is just like a straightforward method. So what we want to do is, so we have like a categorical variable. So this is an example here. We have this name, college, CRO, town, and the rest. So what we want to do in that particular variable, the variable is actually called neighborhood. So we want to count how many times names occur in that particular variable. So name occur of 151, just the count, the frequency, the number of time the variable occur, the particular observation occur. So for this particular variable neighborhood, names occurred there 151 time, this college here occurred there 105 time, this old town 73 times, and the rest. So once we just do this, we get the value count using your pandas. You can just add it to your variable, then use it to train your model. So this is another way to actually engineer feature and add to your predicting power without necessarily using the most common method, which is the one hot encoding and the label encoding. Yes. So after this, now we move to the time, because like Zimnat used to have like this, they have a lot of time features. So we are just going to zoom in into how to like engineer time variable. I know this is actually okay. Before time, mixed variable. Yeah. So like there are some competitions you are going to work with. I think Zimnat had one also. They had one competition that like the variable was mixed. So mixed in the sense that for a particular column or feature, you're having mixed value. You're having a string, you're having number, and maybe you're having like you're just having mixed variables, which is uncommon. So the actually ways to engineer this feature and like actually make sense out of them without disposing them. So this is actually one way. So how we do it is, okay, so let's just take a look at this example here. So we have like a mixed variable here. We have A, B, and C. Then we have numbers from 1 to 19. So a neutral way of doing it will just be, okay, this is actually a funny variable. Let me just label encode it. Label encode in the sense that I'll just give each unique value a particular number. Yeah, that might work and it might not also work, but like there's actually a way to actually make sense out of it without doing that. And another neutral way again will just be that this will cause like a nuisance in my model. So the best thing I would do is drop it. So if I don't want to drop it and if I don't want to label encode it or want not encode it, what other things can I do with this kind of feature? So this is what we can do with it. So what we are going to do is we create two features actually. So we call one numerical and we call one categorical. So for the one I'm calling numerical, for every of the alphabetical or every of the categorical feature, I'm going to remove it and replace it with missing value, which is NaN. Yeah. So I will have only numerical features in this particular column. Then because this is C, this is A, I'll fill it with none. Then I'll create another feature called categorical. So for the categorical, every numerical observation that is there will be filled with missing value. Then I will have only the categorical feature there. So this is actually one way to make sense out of this kind of feature. Then you can now decide a way to like fill your non-value, like any I want to do it, maybe fill the non-value with 0 or just make sense out of it in your own way. Yeah, and there is also another part we would look at. So this is actually a feature also. This is cabin. So this is mixed also. But for this kind of mixed is different from the first mix. So this kind of mixed we have like in a particular observation, we have like both categorical and numerical in one single observation. So this is what I mean. So we have B5, we have C22, we have E12. So one way I will actually do it, one neutral way I'll do it also is using the label or one-hot encoding. But that one-hot encoding may cause like sparsity of the features. So another good way to do it is actually to use the techniques I'm going to show you here. So what we can do to this kind of feature is just extract this number away, then extract the categorical one away. That's the B and C. So this is what I mean here. So we have the cabin, which is B5, C22, C22, and the rest. So what I'll do is create two new features called cabin number. So what cabin number will do is extract the numerical value of this. And what cabin categorical will do is extract the actual categorical value of this. Yeah, that is actually one way of doing it. And actually it will improve, is not a guarantee, but is actually a way to make sense out of the feature. Yeah. Then from here, we just dive into the last part, which is the time engineering dates feature. So there are actually several ways you can engineer your date feature. From a date feature, we can extract week of the year, we can extract months, we can extract quarter, semester, we can extract year, day number, day of the week, is it weekend, time differences in years, months, days, hour, etc. So there are actually a lot of ways, and depending on the kind of problem you are trying to solve, that is actually what you are going to use to engineer your date feature, because not every of the date feature will improve your model. So you just have to look at the ones that will improve the model, or through testing which one works or which one doesn't. So let's just dive into it. So for this particular data set I have here, we have like we have the issue date and we have the last payment date. So one thing you can do first is just try to convert it to date time. So to be able to extract, because like pandas have his own way of extracting date time feature, which will make it very easy for you. So one thing you have to do first is convert it to date time using this. So once it is converted to date time, you can now extract anything you want to extract from it. So for the issue date, we convert it to date time, we have issue date. Then for the last payment date, we convert it to date time, then we have this. So for the first one, we want to extract the week from it. So we just do the t.week, you extract the week So for this particular date, week 48, that's it. Then after that, you want to extract month same way using the dt function. Then you just put month, you extract month from it. That is another one. They want to extract the quarter, like what quarter is it in the particular year. Same way you do it, then you get the quarter. For this particular date is the fourth quarter. Then also want to check what quarter it is for that particular date. So we just actually pandas make it a lot easier. They want to extract year, we do it, then we get our year. We want to extract the day. So for this particular date is the first, then you see it here. Then you want to extract day of week also. Like there are just a lot of things you can do using this. You want to extract weekday name and the rest. Then you want to like get like the time difference between two dates. So you just, since it's the dates are converted to like to date time already, you can just subtract them, you get the difference between the two dates. Yes, then also you can do a lot of things with it. Calculate number of months passed between two dates. A lot of things you can do using the process. Yeah, then we just move to the next one. So the next one is engineering time. So apart from dates, so we can also like focus on trying to make sense out of the time features we are given. So once these are like the old thing we can extract from time. You can extract hour, you can extract minute, second, and the time. So it actually still depends on the problem you are trying to solve. So like not every of the feature in the time feature we improve the model you are trying to build. So you just have to see which one works best. So it works the same way also. After converting your date time feature, after converting your date to time date time feature, you can just use the same function from pandas. You extract your hour, you extract your minute, you extract your second, and you extract everything you can extract from the data. So I'll just go to like a simple case study. This was a competition from Zimnat also. So this is official code. I'll share the link. So we just want to see some of the techniques he used to like engineer feature. So we'll start from this very top. So this is the whole feature engineering. This is the whole feature he extracted. Like this is the whole feature engineering process he did. So for the first one, yeah, I said like this particular Zimna, they have a lot of time date feature. So you can see him using the dt function from pandas. So he extracted year, extracted week of year, month, day of week, and the rest. So this year is just trying to extract feature from the date time feature. So everything here is actually date time feature except this one. So this one is just feature interaction. So what it's trying to do here is customer age as a join date. Okay, so you want to know the age in which a particular user joined Zimnat. So how did he do this? He subtracted birth year from the year in which the user joined. So we call this kind of feature interaction. So feature interaction is just when you are trying to add, subtract, you multiply, or do basic numeric analysis on your feature. So it's called feature interaction. Yeah. Then this is another additional feature I created. So what he did here is multiplied customer age as a join date to month difference. Yeah. Then this is the ratio. So he divided join date by month difference. Then this is another one also. He multiplied join date by month difference. Then this is, okay, this is for the test. He does it for the train, then do for the test. So we call this kind of feature, we call them interactions. So you're just trying to interact two or more features together, and they actually help in improving your model. So for this year, there is actually a high chance that the data will actually be similar. So you're going to have like a lot of, maybe not a lot, but you're going to have like a date time feature and the rest. So let's see the evaluation. Okay, so it's mean absolute error this time. Yeah, so that means it's a regression problem. So we have the claim ID and the target. Yeah, so I think I've done justice a bit to it. So in case anybody have question, so we just use the remaining 34 minutes to answer question, and we are good to go for the competition. I wish everyone the best. Thank you.
Thank you so much, Eniola. So, does anyone have any question? I think you can directly unmute yourself and ask Eniola directly. Once
I
again, yeah, okay. Please go ahead.
You can continue. You want to say something? Yes.
Oh, okay. I wanted to say if anyone has any question, they can just unmute themselves and ask you directly.
Please, I have a question.
All right.
I have a question. Okay, please, can we have
Yeah, I'm listening.
access to the note you just showed us?
That's not actually a question. That's a request, but I'm going to send it. No
Oh,
worries. Can ask
okay.
question or like, is everything clear? You understand everything? That's serious.
It's clear. Understood.
All right then. So nobody have question.
Hi, good afternoon. Please, I have a question.
Hi, good afternoon. I'm listening.
All right. Please, can you show us some stuff on hyperparameter tuning?
Okay, hyperparameter tuning. Are you still there? So
Yes,
for
I'm still there.
For the hyperparameter tuning you're asking for, what do you actually want to see? Is it like grid stage or like
How to
what are
apply
you
it?
concerned about? How to apply it?
Yes.
I actually don't have anything prepared on that, but I'm not sure. Do I have something close to it here? Mm, 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 mm. I don't have anything close to it here, but maybe I'm going to check and send later. But like applying it is should not be a difficult thing. So the way you're going to apply it is like you set um okay, let me just you what you do is just set. Okay, so let's look at this cat boost. So for example, this person that built this model used cat boost classifier, and the person is chose 3,000 as the number of estimator. So what hyperparameter tuning will allow you do is like different ways. Instead of me going directly to choosing 3,000, I can decide to maybe try grid search. So I have like a list of value. So I have, let's say, 100, 200, 300, 3,000. Then I run a grid search. Then what the grid search will do is for every of the n estimator chosen, that's 100, 200, we try to see how the model is performing based on the n estimator. And even without using grid search, you can do it manually also. So you choose your n estimator as 3,000 in the first place. You check your fold validation and see how your model is performing. Then you change the 3,000 to maybe 2,000. You see how the model is performing. You change it to 100. So that is actually just how to apply it. So it's just changing the parameters of your features of your model. Sorry, that's like hyperparameter tuning. Just like changing different parameters. Yeah. So that's basically it.
All right. Thank you. My
Welcome.
other question is it advisable to use AutoML in computations?
It depends. You have to read instructions. So Zindi will provide you with instruction. Let me go to it. So if you come here, you are going to check here rules. So there are some competitions that will tell you that you are not supposed to use like automated. Yeah, this is it. You may use only the dataset provided for this competition. Automated machine learning tools such as AutoML are not permitted. Yeah,
Okay.
so for this particular competition, you can't use AutoML. And just check the instruction. If you can use it, you will know. If you are not supposed to use it, from the instructions, you are going to know as well. Yeah,
Thank you.
welcome.
Eniola, there's a question in the chat.
In the chat. Okay. I can't see any actually.
Okay, maybe I should read it out. He said,
Okay.
looking at the practice data set, we had a column for occupation with 240 different categorical values. How do we handle it? Can you show us a sample of assembly technique? I think that's two questions in one, but the first one should be, how do we handle the 240 categorical variables? And the second one is about assembly techniques.
Okay, so the question is we had 240 categorical feature. So how do we encode that kind of feature? So it will actually depend on the feature. I wish I can actually see the feature now. But it depends on the problem and depends on the feature itself. So for every competition, actually, you are going to be given a data description. So what the data description will do for you is you will see, you like know the kind of feature you're working with. Like it will just explain the feature itself. So for that kind of variable, actually 240 is actually a lot. 240 unique categorical feature in a column is a lot. And it might not also be a lot if the data set is large. So it still depends on the whole distribution of the data and the rest. So there are actually different ways that you'll be able to encode it. One way is actually the label encoding. You can just throw it to a label encoder. One auto encoding will create a lot of features. So that might actually give your model a bias. So I won't advise one auto encoding for that kind of feature. But label encoding will be good to go anytime. And also, if it is a kind of categorical feature, we can extract, let's say, some numerical details out of it. That will actually be one way also to make sense out of that kind of feature. Yeah. And I guess that is it. Then the second one, and I should show like an example of assembled model. I think that person wants me to show a code, yeah?
Yes,
Sorry,
but I'm
somebody say
sorry,
something.
before we move on, yes, it's me. Before we move on, I wanted to talk a bit about that 240 categorical variable. I think I've encountered something like that. I think mine was about 410, if I'm not mistaken. It wasn't for a Zindi hackathon though. Well, yeah, so I don't know. I'm not sure if that was the best method, but there were two methods that applied there. So one was I just fed it into a robust model like that without encoding, knowing that models like CatBoost already has kind of like an encoding method inbuilt in it. So I fed it into CatBoost when I first tried CatBoost. Then when I wanted to improve the model, I used this. I found this in a tutorial, so this might be a useful information. That's what I'm trying to share. I used this. It's still one hot encoding, but it was like top K. So you do like you check the unique variables and the accounts. Some of them are redundant. Like for example, they can be you can have, let me give an example of street names. You can have different street names in that particular column, but they are only appearing once or twice. Also, sometimes you can even see that there are two features that mean the same thing, but because of spelling, data entry errors, they are now appearing in multiple places. Like you can have something like Lagos spelled with capital letter in one place, Lagos again appearing in that place with small letter, Lagos again appearing in that place with LG A or LGS. You see it again in that place, all caps locks. You see it again, it's like that. Like I saw columns like that. So I think there are multiple ways, as Eniola has mentioned, but the key thing there would be for you to do proper data cleaning. You need to check the columns very well. There could be that one entry is appearing in many places multiple times, and you just need to clean it and merge it together. One, or you can try the top K, as I mentioned. Like you can one hot encode, but you do top K. Top K meaning some other features are redundant, so you just do like one hot encoding for the top most like if you have three entries that are appearing more, they are appearing more than any other. Like let's use this Lagos for example again. You see Lagos appearing as a count of 10, Abuja 15, then others are appearing 1 1 1 1. You want to do one hot encoding for just maybe Lagos and Abuja, like that. That's top K, like top most frequent entries. One hot encode top most frequent entries. um I'll try and see if I can find the tutorial for that, and I'll drop it on the chat. So maybe you can try that too. So yeah, that's my contribution.
All right, thank you very much for that. So for the assembling, I'm going to just check if I have. Let me see. I'll just go to Collab. I should have something. I'm not sure, but let's check. Okay. Same thing. Okay, so this is an example here. So for this particular competition, I don't have the name here. So for this particular competition, like I had two different predictions from two different. So it was a regression. Is it regression? No, it's not a regression problem. This is a classification problem actually. But we were told to predict the. We were predicting the probability. So we're predicting probability here. So what I did for this particular competition is for this first part, that's like for the prediction of the first model. So this prediction here is for my first model, then this prediction here is for my second model. So this is actually a very simple way to assemble. So what you do is you take 0.7%, that's 70% of the target of your first prediction, and you take 30% of the second one, then you just add it. So you add it, you name it as stack, then you submit. So this is actually a very like simple and direct method to assemble your model. But there are still actually like more advanced and technical ways to go about it. But like this is one of the easiest way you can do it without having to stress yourself out. Yeah. So anybody with any question, or is this answer clear? Let me know if it is clear enough before we move.
Yes, the answers are clear. Thank you very much.
Yeah, you're welcome. So anybody else with any question before we call it a day?
Hello guys. I'm having a simple question. Please, what do you think is better? Should I use TensorFlow or scikit-learn? Which one do you prefer?
Using anything will actually depend on the problem you are trying to solve. You're asking sklearn or TensorFlow. So sklearn is actually a library you can use in any way. You can use it for deep learning tasks or even the normal classification tasks. But if you want, maybe your question is maybe TensorFlow or PyTorch. If you are having, let's say, a computer vision problem, you may actually want to decide, okay, am I supposed to use TensorFlow or am I supposed to use PyTorch? And if it's a maybe natural language processing problem, you can decide, okay, I want to use PyTorch or Fast AI, or I just want to use Keras or Simple Transformer. So it actually depends on the kind of problem you are trying to solve. And sklearn can be used in different places because, like, from sklearn, you can decide you want to preprocess maybe your neural network if you have transformed it to an array. So it's not you can't actually like maybe separate it from, say, sklearn TensorFlow. I hope you get it. Is that clear? Yeah.
Yeah, it's very clear. Thank you very much.
Yeah, you're welcome. I guess that's all. We don't have any question again, so I'll leave it to Madia. Thank you.
Yeah, thank you so much, Eniola. Thank you for your time today. Thank you for putting us through the section.
You're welcome.
So thank you all, to everyone else that's joined the section, and I hope you found it helpful, and hope you keep on practicing on your own. So we might have another section later in the evening, with Sayed. Once that is confirmed, I will post that on the group. So until then, keep practicing and happy hacking, everybody. Yeah, one more announcement. We are going to have some support. So I'm going to be sharing a very important announcement soon. There are some hubs that are partnering with DSN and would like to support all of you with light and data. So most of the locations that we've been getting for is Lagos and Ibadan. I'm not sure about other places, but we're working on it. But if you have link to any hubs that you think that will be willing to partner with us, please share. We're trying to make this seamless for everybody because of the current challenges we're having with light and data too. Data can also be hassle, so we are seeing how we can partner with some hubs that would just provide you with light and data, and all you need to do is go there and stay for Saturday and Sunday to participate in the hackathon. So once we have all the information, we'll share. But as I mentioned before, we've only gotten for 2 locations so far. So if you have any hubs that you think would be willing to partner with us, please reach out, and enjoy the rest of your day, everybody. All right, bye.
Thank you very much. Bye.
Yeah.
Oh, thank you.